Welcome to Justice Today, the official podcast of the Department of Justice's Office of Justice Programs, where we shine a light on cutting-edge research and practices and offer an in-depth look at what we're doing to meet the biggest public safety challenges of our time. Join us as we explore how funding, science, and technology help us achieve strong communities.
Hello and welcome to Justice Today. We are talking about vaping today because it's not what you think. My name is Frances Scott. I'm a program manager in the Office of Investigative and Forensic Sciences here at the National Institute of Justice, and I'm joined today by Dr. Michelle Peace. Dr. Peace is a tenured associate professor in the Department of Forensic Science at Virginia Commonwealth University, and she is a founding faculty member of that department. Dr. Peace, welcome.
Well, hello, Dr. Scott. Thank you for having me today.
So you were one of the first to begin researching e-cigarettes and vaping since their rise to popularity in the U.S. What prompted your interest in this research topic?
Thank you for that question, because it's really a story of developing relationships with undergraduate students. And I love telling the story. So, electronic cigarettes, they have a long history in the United States, actually. Um, but the modern electronic cigarette really didn't hit the United States until roughly 2006. And so the devices were really niche products, and so they weren't really widespread like we think about them today. And so before they came to the United States, they actually made their rounds around the rest of the world. And so they were really popular in other marketplaces. The European marketplace, is where they really caught on before they caught on here in the States. And so I had an undergraduate student who was studying abroad as part of her bachelor's degree. And she comes home and we have an advising meeting. And she has been studying in Europe, and she comes into my office and she's super excited. And she says, Dr. Peace, we really think you need to study these things called electronic cigarettes. And I had no idea what she was talking about. And so right while she's chatting, I'm Googling, and and she's talking about how pervasive they are. Everybody is vaping, and it's fun and it's cool. And so I was really frank with her, and I said, well, why do I care? Right, as a forensic toxicologist, why do I care about how people consume nicotine? We had a conversation about that, and I just rested in it. This was probably 2011, 2012. And I'm a little bit of a slow thinker, and so one day it just dawned on me, oh my heavens, people are going to be able to manipulate the devices, and if they can manipulate the device, then they're going to put whatever drug they want into them. So we actually started trying to collect some preliminary data, and recognized that yes, indeed, that was going to be true. I reached out to a number of colleagues who work in crime labs, and just to say, hey, are you guys testing these things called e-cigarettes? And for the most part, nobody was, except for one lab that said, yeah, we are collecting them over in a shoebox. I said, do you mind running some of those for me to see if there's anything of interest in them? And so he did, and there was. So that's how that was all preliminary data that we put into our first grant to the National Institute of Justice.
And we are at the NIJ are very happy for that conversation and proud to have funded you through the years and to have been, with you on the forefront of this research.
Yeah, I appreciate you. I appreciate you seeing this when we felt as though it didn't have a snowball's chance, right? On a hot day. Uh, so we appreciate that the NIJ really took that risk.
So before we dig into our discussion on your research, can you explain vaping to our audience? I think we all think we understand it, but I think there are some misconceptions that you could clear up for us. How does it compare to traditional smoking.
Yeah, I think I appreciate starting with that conversation. Because I think you're right. There's some misconceptions and frankly, some mythologies that have been promoted about what vaping is. And so I'll start talking about the traditional cigarette, because when you think about a traditional cigarette and that you are lighting that, it's combustible, there's, you know, there's fire, is that you're still generating something that's called an aerosol. And we think about that in terms of its smoke, but it's really an aerosol. And aerosols are made up of millions of tiny droplets, and those droplets have different sizes. Well, the same thing happens with an e-cigarette. So vaping uses a device called an electronic cigarette that is made up of a number of important components that no matter what that e-cigarette looks like, all of the components exist. So the most significant component is called the coil. And that coil is typically metal, and it heats up to roughly, depending on the settings, 250 to 1,000 degrees Celsius. So it gets so hot. And that coil is in touch with what we refer to as the e-liquid. There are some industries that call them e-cigarette formulations. We just refer to them as e-liquids. And that e-liquid is made up of chemicals, and they're made up of common chemicals that are called propylene glycol and vegetable glycerin. They're commonly known as PG and VG. And in the PG and VG are other chemicals. So, of course, our pharmacological agent, in most instances, that's nicotine, but also lots of flavoring compounds and solvents are also in that e liquid. So, when that coil gets really hot, it immediately vaporizes that e liquid. When it hits the air, it pulls water out of the air. And in that process, millions of tiny droplets are formed. So the mythology is that, well, vaping is just, water vapor. And that's mythology. That's an incorrect assumption. That's a misconception. Yes, it's pulling water out of the air, but that aerosol cloud still has all of those chemical components that was in the original e-liquid, plus other chemicals that are formed when those chemicals hit that heat and they degrade. So there can be a complicated chemical profile inside of that aerosol cloud as well that the consumer is inhaling.
And that someone walking behind them inhaling their cloud is also inhaling now, without intending to, right?
Yeah, there's some interesting and good research happening right now, not in my lab, but with other investigators, in which they're evaluating the nature of that secondary, what we refer to as secondary smoke. Right? It's not smoke; it's an aerosol cloud. Um, and so secondary exposure is important to appreciate and to understand. I think what's also interesting is that there is some good research happening with tertiary exposure, meaning that when that aerosol cloud lands on objects, furniture, clothing, right, there's a tackiness associated with it. That's because PG and VG are sticky. And so, right, so there's definitely some concern that people who have a tertiary exposure are also getting exposed to whatever that pharmacological agent is. And there are certain bodies, certain people who are really concerned about children being exposed to nicotine through a tertiary exposure, right? Because even nicotine is toxic.
That's fascinating. Thank you for that explanation. So, most of your research has involved, as you said, those other interesting things, drugs other than nicotines in that e liquid. I know there's a lot. Can you summarize just some of your findings and kind of that research path?
Yeah, it's one of the things that we didn't fully appreciate when we started was that there wasn't a lot of research, there wasn't a lot of data as to how the devices work, and how effective are they. And certainly there wasn't any data that really compared the devices head to head. So I don't want to say there was none. There's been aerosol research at institutions for decades. And some of the most important aerosol research is some of it's here at VCU, some of it's University of Maryland, some of the most important aerosol research. So it wasn't like we didn't know anything, but this thing that's called an electronic cigarette felt new. So we had to collect a lot of data, just to figure out how do the devices work so that we can then figure out how to manipulate them. So one of the studies that we first started, right? Because you got to figure out also, well, how do you test an e-liquid? Like, what is that going to look like in the instrument? So we just started buying a bunch of e-liquid products, and we started noticing that what was on the label was not what we found in the bottle. And so that became, it was at first interesting. And I thought, is this widespread? So we started getting e liquids in from friends all over the nation. And and my question was, they need to be made in the United States. So it looked like we were the first ones that really published on this is what's in the U.S. marketplace. At the time, the e-cigarette industry was unregulated, and so when you have an unregulated industry, there's always issues around, is the industry going to adhere to certain quality assurance standards? So we really demonstrated that in the early days that there was what was on the bottle, what was in the bottle was not how it was labeled. We've demonstrated that there's thousands of potential flavoring compounds, and those flavoring compounds are in solvents, and those solvents are sometimes in the final products that the consumers are using. So we found an industrial solvent called GBL in some products. Um, we've certainly kept an eye on drug user forums to see how they're talking about how they use the devices to vape other substances and what they do to get those other substances into their e-liquids. How do they manipulate the drug to get it into the e-cigarette or the e-liquid? And then, one of the things that we right, I mean, this is the great thing about research, is that you don't know what to anticipate next until you're down a path. Is we discovered that some of the e-liquids that we had in house had ethanol in them, and so we were like, why is there ethanol in e-liquids? And so we did a survey of products and found that there were some products that had a substantial amount of ethanol in those e-liquids. And at the time, our lab found many products that were as much as 20% ethanol. And since then, we have found some e-liquids that have as much as 30% ethanol in them. So, in terms of drugs, we have certainly, collaborated on cases with and seen instances in which, and also found e-liquids that have methamphetamine in them and synthetic cannabinoids, and opioids as well in the e-liquids.
There's a lot to unpack there, but I want to pull on a couple of those threads. What about the coil itself? You mentioned that it heats up to incredibly hot temperatures. What did you find about what that does to the actual coil and the aerosol?
Because of how we got funded, right? National Institute of Justice, and thinking about, death investigations and toxicology. And, it was the question that I had was, well, if somebody needs to say the overdose happened because they inhaled this product from an e-cigarette, I wondered, well, how do we pin that? So so I was thinking about the fact that, that e-liquid is in contact with a lot of metal in the device. And so we found that actually e-liquids themselves have trace metals in them, which wasn't all that surprising. But what I really thought about the source of the metal was the coil. And so, right, so coils are made up of, at the time we did the research, there was two predominant metal compositions, and so we took a look at both of them to find out, one, what is the metal content of this, and what happens when it gets heated, just in normal heat cycles. And so, what I thought about was, well, if there's enough metal coming off of that coil, is that metal going to be like a residue in somebody's mouth or their upper respiratory tract? If there's enough. So I was interested in, are the coils flaking? So we ran a bunch of studies where we heated the coils in a standard fashion, and then we ran them through a number of heat cycles up to 150. And at certain points, we stopped and looked at the coils under scanning electron microscope and under a regular stereo microscope. And we demonstrated that the coils are flaking significantly even after 50 heat cycles. So you can literally see the surface of the metal bubbling up and off. So then the next question was, well, it's probably because it's heavy, right? We thought, well, it's probably condensing on the inside of the mouthpiece. And we swabbed the insides of mouthpieces, no metal. And so we're like, okay, so we ran the aerosols through a filter to capture, was there going to be metal on that filter from the aerosol? And sure enough, that's where the metal was.
So e-cigarette users are actually breathing in aerosolized metal particles into their lungs.
Yes,
Wow, not just water vapor.
not just water vapor.
So you talked about all of these millions of droplets and them being a variety of sizes. What does that mean for the absorption, the intake from a forensic toxicology point of view? Is this is this a good transport mechanism from the point of view of getting into the lung tissue?
So what happens when there's a condensation aerosol form, right? And when you inhale all of those millions of droplets, and this is where there's lots of rich data, is that the bigger droplets are going to get trapped in the mouth and hit the back of the throat. So you think about when you're inhaling, you're inhaling this cloud into your mouth, and then it has to essentially take a 90-degree turn to get into your respiratory system, into your lungs. And so bigger droplets are just big, right? We kind of intuitively know that it takes big things longer turns to make a turn. And so, because your mouth is so small, your throat is so small, big droplets just impact in the mouth and impact in the back of the throat, and they never make it into the lung tissue. And so, some of the studies that we did, because we were interested in, if you change the voltage, if you change the chemical composition of your e liquid, do the size of the droplets change? So what happens is that the small droplets are small enough to make that 90-degree turn into your lung tissue. And the very small droplets will make it into the very deep lung tissue where there is interaction with the blood system, right? And that's where you get oxygen and carbon dioxide exchange, but that's also where drugs cross into the blood system. So inhaling substances is a really efficient way to consume drugs, to get into the blood system fast and to have an effect fast. So we demonstrated that there were some parameters that really didn't change the composition of the droplet sizes, and some moderately changed the composition of the droplet sizes. But still, no matter what the parameters were, whether it was the recipe of the e liquid or the voltage of the device, you're still going to get sufficient particles, sufficient droplets into the deep lung tissue where there's going to be an exchange into the blood supply. So at the end of the day, that e-cigarette technology is a very effective tool to getting drugs into the blood supply and into the body for an effect.
And very quickly, as opposed
Very
to
quickly.
taking things orally or other, methods.
Yeah. Yeah, very quickly.
So you mentioned that the e-cigarette market was not regulated at the time that you began your research. Is it now regulated? Are there limitations to those regulations?
Yeah, so when the electronic cigarettes began to be imported in 06, 07, the FDA did think that they had regulatory control over them. The FDA had done a lot of work in the 80s and the early 90s to regulate the tobacco industry. And so the regulatory language said that they regulate tobacco and tobacco products. And when the e-cigarettes started being imported into the states, the companies that were importing them essentially told the FDA, "You do not have regulatory oversight over the electronic cigarette because these are not tobacco products; they are nicotine delivery devices." And so the FDA then had to, essentially spend a lot of time developing and redeveloping regulatory language, and that requires Congress and the president's office to give them some direction and authority to do that. So that all takes time, and then once you have the green light to do that, then you have to develop that language, and building that consensus language takes time. So it was almost a decade before the FDA was really able to promulgate the regulations for the electronic cigarette. And so, you know, is it what I think is robust and thorough? I think there's room for improvement. I think that there needs to be a real consideration over what kind of chemicals can be put into an e-liquid. So some of the really early language in the unregulated industry was that, well, we're using chemicals that are generally regarded as safe by the FDA. So they're not harmful. And so that was some of the other mythology that existed, for the general public to think that they were safe products. And the term generally regarded as safe means that a chemical is safe to eat. And what consumers didn't appreciate was that these chemicals that are being used in e liquids are not generally regarded as safe to inhale. Many or most of the chemicals that are used in e liquids are known toxins, irritants, carcinogens in lung tissue. There is good research that is emerging right now that is demonstrating how chemicals that are used in e-liquids are suppressing the immune system in the lung tissue and propagating lung diseases. And so, when we think about that marketplace being unregulated for a long time, it gave a lot of bandwidth for essentially for that industry to, I'm just going to say it, get its hooks into the consumers. And then reversing that is hard. So I think that the regulations really need to put more pins in. You can't put industrial solvents into e-liquids. And have a list of chemicals that are forbidden agents in an e-liquid. And companies have to put in applications to be approved to market their products now and sell to the consumers. And I don't know that has all gone far enough. We're still not seeing labels on the packages in terms of what the chemicals are in those e-liquids. I think consumers If you choose to consume nicotine, I think they need to know what's in those e-liquids so that they can make informed decisions about what they're consuming.
Absolutely. You mentioned lung disease associated with e-cigarette use. In 2019, there was a rash of mostly young, apparently healthy people hospitalized with e-cigarette or vaping use associated lung injury, which is long, so we say EVALI.
Mhm.
What causes EVALI and why is it associated with vaping and not with traditional smoking?
So EVALI, when young people started really reporting with significant lung injury, and many patients died from these lung injuries. And when you go back and you evaluate the population of people who were officially diagnosed as having EVALI, and and you do those studies to find out, well, what's the origin, right? Like with any kind of disease state that's progressing through a population, what's the origin? We have recent experience with that, right? So um, what they found was that many of those patients had been vaping gray market cannabis products, and that in some of those gray market cannabis products, there was a compound called vitamin E or vitamin E acetate. And, they were able to collect fluid from the lungs of some of those patients and demonstrated that there was vitamin E acetate in the lung tissue of some of those patients. And uh, so now we have a chemical that is is common to a lot of those patients. But I will say that that wasn't the only compound, right? There were lots of patients that A, didn't get their lung fluid tested, and B, actually never said that they vaped a gray market THC product or vaped a THC product at all. There were patients that were diagnosed with EVALI and significant EVALI, that only vaped nicotine products. I consulted on a case in which a young man had been having uh, some kind of lung injury on and off for years, and it was always attributed to he was just prone to the flu. And so when they actually figured out the pattern that he would get the flu right around the time that he was vaping a lot. So he had a lot of lung congestion, fevers, and because he was having lung congestion and not feeling well, he'd stop vaping. So then he would get better. And then when he was better, then he'd start vaping again, right? So he was on about a 4-month cycle of this. And that young man was never vaping a THC product. He was vaping a nicotine product. And so I think we can't lose sight of the fact that chemicals, when you inhale them, are going to create injury to tender lung tissue. And that injury is going to cause the body to mount an immune response, right? It's going to send fluid to that response. You're going to get more cells in the lung tissue to try to repair that chemical injury. So, so generally speaking, that lung tissue is being bombarded by lots of chemicals when you vape. Not the least of which is just PG and VG. And so, what we understand about PG and VG is that they're what we call hygroscopic, meaning they attract water. So, we and I'll be honest. So in the really early days, we had started the research. We would just get when we in our studies we weigh the e-liquid before and after every time we use it in a device. And so we had just set bottles of e-liquid, left them out on the lab bench, and the student would come in the next day and they would be heavier. And I'm like, well, we have to make new e-liquid because I don't know why that gained weight overnight. So it gained weight because it was absorbing water out of the atmosphere. So then we had to, then we had to buy an environmental chamber and with desiccator in it, right? So what happens when you inhale PG and VG is that it is drawing water out of your lungs. You're like, oh, there's water in your lungs? Yes, there's water in your lung tissue. There's a very thin coat of water in your deep lung tissue that facilitates oxygen and carbon dioxide exchange. Very thin layer of water. And so when you inhale PG and VG, it's going to absorb that water. So your deep lung tissue is going to dry out. When it dries out, that creates injury. So we think that, we can look at PG and VG as chemicals that are going to cause lung injury, in addition to all of the other chemicals that are in e-liquids as well.
And I think that underscores your previous point about generally regarded as safe, the difference between something like vitamin E that I assume is safe to take as a vitamin but not to inhale, and probably the same for vegetable glycerin.
Yeah, PG and VGs, and those compounds are in everyday products that we eat, from toothpaste to cheese.
We just don't breathe them unless we're vaping.
Right.
So you talked about the ethanol that you found. That was kind of a shocking discovery and in high concentrations. And so I know that led to your recent NIJ funded research that includes a clinical study to determine the impact of vaping ethanol, both on actual intoxication and as related to, for example, preliminary breath tests, like might be done in the case of a DUI stop. So I know that research is ongoing. But what have you found so far?
It's a big collaboration to lift off this clinical study. So we were really interested in, early on when we began wrestling with this, when we recognized that e-liquids contained ethanol. We were really concerned with, of course, the preliminary breath test. And and I'm rolling around in, well, what are some of the other implications? Because there is very little research on the impact of inhaling ethanol. We began thinking a lot about other implications, not just with DUI investigations, because there are other industries, agencies, organizations that will use the preliminary breath test, like substance use treatment centers use a PBT, preliminary breath test. Some drug courts will use this. There are some drug workplace drug testing locations will use a PBT as well. So it's not just about DUI investigations. We also started seeing where defense attorneys were posting on their websites that if you vape, they can essentially help you get off of a DUI. And so, like, I was stunned at the hubris of that. But certainly that seems like a pretty bold claim with no scientific foundation. So our first clinical study was, we had people come in and vape either a 0% or a 20% ethanol e-liquid. And we had the police departments conduct the standardized field sobriety tests. We had the participants self score. So they had to take little quizzes about how they felt after they vaped ethanol. And, they were questions like, did it make you feel sick? Did you feel impaired? Do you feel like you can drive? There were probably, I don't know, 30, 35 questions that they had to answer. And then, of course, we're conducting the PBT and the evidentiary breath test as well at certain time points. And so one of the things that we wanted to do was essentially test the question, when police or if police observe this deprivation observation period, meaning that they have eyeballs on the person to make sure that they're not belching, to make sure that they don't have anything in their mouth, to make sure that they're not putting anything into their mouth like a mint, and then they administer the preliminary breath test. And so the question was, is that period of time long enough? So a 15 to 20 minute wait period, if somebody is belched, or if there is alcohol in the mouth, 15 to 20 minutes is a long enough time for that ethanol to absorb across the mucous membranes of the mouth. And because we want the PBT to only be measuring ethanol that comes out of the deep lung tissue. So the question was, because ethanol is in those e-liquids, and e-liquids are so sticky, is that 15 to 20 minutes long enough for ethanol to absorb across all that stickiness? So we did a lot of PBTs and EBTs immediately after vaping. And so we showed that immediately after vaping, 20% ethanol, that the PBT picked up ethanol. And we had one participant actually blew a .07. And so, that has lots of implications, in all of those industries that we discussed, particularly if there's an industry or an agency that has a no tolerance policy, or we're talking about a child. And so, we thought that was really important. The other, I think, really important piece that came out of that poked a hole in this hypothesis that defense attorneys had, was that the PG and VG do not give a false positive. Every single study that we ran that was 0% ethanol was negative, had no ethanol reading at all. So we were not surprised by that, but this is the piece where a negative result is an important thing to publish. So we're really excited to get that into the scientific literature. I think the other piece that is, we have received, I couldn't even tell you, more than 40 emails or communications from people saying, I have failed my drug test for ethanol and I don't drink. And so one of the things that we're going to be testing in the second clinical study is that we're going to be pulling blood, urine, and oral fluid in the second clinical. And so patients are going to be drinking ethanol. So we're going to try to get them to a .08, and then we're going to have them vape. And we're going to have, they're going to vape 0 or 20% ethanol. And then we're going to have, of course, placebos in that as well. And so the question is, for those who are just vaping ethanol, we're going to be looking at a number of biomarkers that have forensic and clinical implications. Is that, does vaping ethanol give a rise in those biomarkers that are evaluated by a number of industries? Is somebody going to test positive? So we have our officers trained right now, and we're literally calling our database to see if anybody's ready to come in. So we're literally launching that study now.
That's fantastic.
Yeah, we're excited about it.
Well, I appreciate you taking time to talk to us today, Dr. Peace. What would you most want our listeners to understand about vaping from all of your copious research findings?
I think the most important thing for a consumer to do when they choose to consume anything is that they are able to make an informed decision about what it is that they're consuming, and understand what all of the consequences could potentially be, And if we don't have a transparent industry that is allowing the consumer to make those decisions, then you know they could have adverse events that you know that they don't understand. And if they don't understand it, are they reporting those to their physician? I think the other piece is that physicians also need to understand that there are could be serious consequences for their patients who are also vaping, and that needs to be part of a conversation with the physician. And so I think at the end of the day, it really is about consumers making informed decisions and knowing what they are consuming and what those consequences could be.
That's a great takeaway. The science of vaping and e-cigarette use is complicated, so if you choose to partake, be an informed consumer and understand that vaping is probably not what you think. Thank you, Dr. Peace, and thank you to all our listeners for joining us.
Yeah, thank you. I appreciate the time.
To learn more about today's topic or about NIJ, visit the links in the episode description and join us for new episodes every month. Opinions or points of view expressed in this episode represent a consensus of the authors and do not necessarily represent the official position or policies of the U.S. Department of Justice. Any products and manufacturers discussed in this episode are presented for informational purposes only and do not constitute product approval or endorsement by the U.S. Department of Justice.